Good morning, friends. Today in this class, we are going to discuss a completely new concept. And this concept is widely used to write the programs in real time use. So most of the programs that we write are going to be used in real time applications. And when you write a program and execute that program in the laboratory, that program behavior is something different, and same program whenever it is executed in real time situation, then the program will behave differently. So in a real time situation, the concept which we are going to discuss is widely used. And this concept is called dynamic memory management. Now we are going to discuss some of the techniques that are used, which are useful for real-time programming. What is the importance of this dynamic memory management techniques? Here for this class in dynamic memory management techniques, we are going to deal with the topics of introduction first, and then we are going to look into the memory organization, and then we are going to look into how the dynamic memory management functions can be used efficiently to handle the memory requirements of the program at runtime. Runtime means execution time. And then I will give some programs for practice. Those programs you can execute in your home on your computer. Then we are going to discuss some important questions and the assignments that you have to write. So let us start our class with the introduction to dynamic memory management technique. See, when we are writing programs and executing the programs on the computer, most frequently we come with the data that is dynamic in nature. Dynamic in the sense the requirements of the data are going to change from time to time. Sometimes data may be bulk in size, and sometimes we do not have much data. When the data is more, you need to have more space in the memory to store all that data. When the data is less, you need little amount of space in the computer memory, because you have less data, less memory is enough. Like that, in real-time applications, the requirements of the data is dynamic. Dynamic means sometimes you are going to have large amount of data, bulky data, and sometimes you are going to have less amount of data. Means the requirement of the data during the execution of the program we cannot guess. And even if you guess, when you are going to write the program, even if you guess, sometimes your guess may be wrong when that program is being executed. I will give one example. Suppose you take an example of a supermarket which maintains the details of all its customers, like the customer name, their addresses, their profession, and the number of persons in their home, like that, etc., etc. Some details are maintained about each customer visiting that supermarket. And as time goes on, the new customers are going to visit the supermarket. And whenever the new customers comes to the supermarket, then usually the persons in the supermarket, the employees of the supermarket, they try to take the details of the new customers and they enter in their system. They maintain the data of all their customers. Means when new customers are to be added to the application, then definitely it occupies some space. As the number of customers are going on increasing, you need to allocate more and more space in the computer. And similarly, suppose if you have, this is one end, similarly if you have at the other end, there are some customers who are not visiting supermarket from the last 1 or 2 years. Then the employees of the supermarket or the administrator of that supermarket probably identifying all that customers, and then he wants to delete the data of those customers. When the customer details are deleted, then some space occupied by that data will be released, and that data can be used for some other purposes. Like that, as a new customers are added, you need to allocate more amount of space, and then when the customers are deleted, then you are going to get free amount of memory space. Like that, the data requirements are dynamic in change. But can we handle the situations like this? That is, when you wanted to have more space for adding the details of new customers, are you going to create the space at a runtime when the program is executing? And similarly, when the customer details are deleted, whatever space is occupied by that data, can you release that space which you are not going to use, so that that memory space can be used for some other purposes? With the programming techniques, whatever we have discussed till now, so it is not possible to allocate memory at a runtime or to free up the memory at a runtime, because we have discussed few techniques like arrays, structures, which are going to deal with the large volumes of information, large volumes of data. So in both structures and arrays, the requirement of the memory should be specified well in advance at the time of writing the program. Means at the time of compilation itself, you have to tell. When you are declaring array, what we are doing, we write the statements like this: int a of 20, int a of 20. Int a of 20 means, what is the meaning of this int a of 20? Means you are telling the compiler that you are going to store maximum of 20 integer values at the time of running the program, so that the compiler will allocate the space required for storing only 20 elements. Now consider the case 1. Suppose at the time of running the program, suppose you are having only 5 integer values, but you have requested the compiler the space for 20 integer values. But when you come to the execution time, you have only 5 integer values. Means you are storing only 5 integer values in the array. The space you have requested for 15 more integer values becoming waste. It is going to be unused. You cannot release that space. Once the space is allocated using arrays, that space cannot be changed whether you use it or not. Means in the arrays, when you request for more space and you have less data, the space you have requested is being wasted. A lot of space in the array is wasted. This is case 1. And coming to the other case, case 2, where you have requested space for storing 20 integer elements by declaring int a of 20. But when you come to the execution time, you found that you are having 30 integer values to store. When you have 30 integer values to store, can you store 30 integer values? It is not possible, because we have requested, we have informed the compiler that we are having only maximum of 20 integer values. So compiler has allocated the space required only for 20 integer values. Remaining 10 integer values we cannot store. So using arrays and structures, it is not possible to get the required amount of memory space at a runtime. Similarly, when there is unused space that cannot be released at a runtime. So that is the limitations with arrays and structures. And if you want to manage with the memory at runtime, then we have to depend on dynamic memory management techniques. Fortunately, C language supports few dynamic memory management functions. Using that, it is possible for us to manage the memory at runtime, so that if you need more space, you can request for the space and you can get it. And when you have unused space, then you can release that space to the system, so that the system is going to use that space for some other purpose. So this is how you can deal with the memory at runtime using dynamic memory management technique. See some of the points I wrote here. Arrays or structures, when you use, you must mention the storage space requirements at the compilation time, so that the compiler will allocate the required amount of space to you. And this space, once it is allocated to you, it cannot be changed. And then the requirements of increasing the memory or decreasing the memory at a runtime cannot be done by using the techniques which we have discussed till now. So therefore, since C language is supporting dynamic memory management functions, so those functions we are going to use to efficiently handle the memory at a runtime. So there are 4 functions which can be used for this purpose. One is malloc function, second one is calloc function, third one is realloc function, fourth one is free function. And out of these 4 functions, memory management functions, first 3 functions can be used for allocating the required amount of memory at a runtime. And the last function, free, the name itself representing that it is used to release the unused space at a runtime, so that that space can be used by the system for some other purpose. That is how we can use these 4 memory management functions. Allocating the memory or releasing the memory at a runtime, means at the execution time, is called dynamic memory management. Again, I am repeating the definition of dynamic memory management. Allocating the required amount of space or releasing the unused space at the time of running the program, it is called dynamic memory management. And to dynamically manage the memory, we use dynamic memory management functions. C language has 4 built-in memory management functions. These functions are malloc function, calloc function, realloc function, and free function. These are the 4 functions. These we are going to use. And before going to look at these functions, let us see first how the computer memory is organized. This is for an idea. We will see how the memory is being organized. A computer memory, usually it is a RAM memory. A RAM memory of the computer consisting of crores of locations, memory locations. And some of these locations are reserved for the computer. Usually, this area of the memory is called system area. or system region of the memory. And this part of the main memory cannot be given access to the user or to the user programs. This is the most restricted area. As soon as you switch on your computer, your main memory is identified by the computer and it is going to be divided into few parts. The first part is the system part, and this part of the main memory is used only by the operating system. Operating system programs are loaded in this area of the memory. So this area is called system area, and all operating system programs are not loaded because operating system contains lakhs of programs, and all that programs, they are not loaded into the main memory. If all that programs are loaded into the main memory at a time, so then your computer main memory is not sufficient to hold all that program. So only the core portion of the operating system, the most required programs from the operating system, which are used to maintain the computer system in a stable condition, and those functions, those programs are loaded into the system region. And it also contains, operating system is also containing many service programs, and these service programs are loaded into this region of the memory whenever user uses that service. Whenever user requests for that particular service from the operating system, then operating system takes that program and loads into the computer memory. In the computer memory, those programs are stored in the system area. Means the system area is the area where only operating system programs are loaded and no access is given to the user to this location. And then coming to the stack area, this stack area, the importance of this stack area is, it is also used by the operating system and the computer hardware, especially the CPU, central processing unit, combinedly they use this stack area, stack region of the main memory. What is the importance of this region? Stack region, when you go to third year, you are going to study operating system at a second year level or third year level, then you are coming to know the importance of this stack region. Stack region is used by the CPU whenever it is performing a context switching, whenever it is moving from one function to other function. The variables related to the function will be stored, will be pushed onto the stack, and then it will move from function 1 to function 2. Means whenever moving the CPU from function 1 to function 2, means suspending the execution of function 1 and then going to the function 2 and executes function 2. And when the function 2 finishes its execution, then CPU comes back to function 1. So moving from function 1 to function 2 and coming back from function to function 1, it is called context switching. First, context switching is moving from function 1 to function 2. And once function 2 is executed, it is coming back from function 2 to function 1. Again, another context switching. So during this context switching process, it stores all its variables and the computations it has done till that point of time, and then results produced, intermediate results produced till that point of time, everything it pushes onto the stack and then jumps to the other function. That is how stack region is used. Means stack region is used to store the local variables of that particular function. Local variables are used to hold the intermediate results. For storing that, this region of the memory is used by the operating system. And here also no entry is given to the user or user programs. These two regions of the main memory are restricted regions. So user programs are not permitted to enter into these regions. Next, user area is there. The user, some portion of the main memory is reserved for user, and this area of the main memory is reserved to the user, to enable the user to store the user programs, and whenever user want to execute some programs on the computer, user program will be loaded into the user area. So that is called function statements. Your programming statements are loaded here, and your program, if it is making use of any global variables or external variables, then they are also loaded into the user area. So user region of the memory is used only by the user to execute the user programs. And the space that is there between the stack region and the user area, it is called free space. Means some portion of the main memory is free. And this free memory is used by the C programs to allocate the required amount of space based on the user request to the user programs during their execution. So when you are making use of dynamic memory management functions allocate the space from this region of main memory. So that region of main memory is called heap region. So from the heap region, space is allocated by the memory management functions to the user programs based on the user program request. So because of this reason, the heap region space, sometimes it will be decreased, sometimes it may be increased. Because dynamic memory management functions, if they allocate some space to the user programs, automatically heap region is decreased because its space is used by the user programs. And when that program, after using the space, if it releases, that space is again getting added to the heap region. So heap region size increases. Means the heap region size, sometimes it will be shrinks down and sometimes it expands, it grows based on how the memory management functions are allocating the space to the user programs. That is how it is used. Now let us see dynamic memory management functions. Dynamic memory management functions, they are used to allocate the space to the user programs at runtime. And we have already discussed that we have 4 functions in C language: malloc function, calloc function, realloc function, and free function. So these 4 functions we will see one by one. First we will start with malloc function. What is the malloc function? So all these functions are used for allocating the space. First 3 functions are used for allocating the space at a runtime, and the last function, free function, is used for releasing the space at a runtime. First we will go with malloc function. Malloc function is used to allocate a required number of bytes of space or a single large block of memory of specified size at runtime. That is the use of malloc function. Malloc function is used to allocate a single block of memory of specified size. That is the importance of malloc function. Malloc stands for malloc. M means memory, alloc means allocation. Malloc function means memory allocation function. Memory allocation function, malloc in short, it is used to allocate a single block of memory of specified size. And this block of memory contains so many bytes of storage space. And all these bytes of storage space is contiguous bytes. Contiguous bytes means sequential locations, one after the other, they are there in the computer memory. So that is called contiguous memory location. So all memory management functions, they allocate contiguous space in the computer main memory. malloc function is used for allocating single large block of memory of specified size. And its syntax is very simple. See here. PTR means the pointer equal data type star means it is a typecasting operator. malloc byte size. How many bytes of storage you want? So that you have to specify here. Suppose if you want to have 100 bytes of storage space, that 100 bytes of storage space is allocated by malloc function. And then it returns a pointer pointing this 100 bytes of storage space. The first byte of this 100 bytes of storage space. It returns a pointer, and this pointer is of type byte, pointing the first byte of the allocated memory. You can allocate the memory of 100 byte space, 200 byte space, 300 byte space. And after allocating that amount of memory, malloc function returns a pointer which is of type byte. And this pointer points out the address of the first byte of allocated memory. Since it is a wide pointer means it is a generic pointer. Wide pointer means it is a generic pointer. Since it is a generic pointer, it can be assigned to pointer of any type. So therefore we are using typecasting operator before the malloc function. Means malloc function is preceded with a typecasting operator. Since malloc function is returning a pointer of type wide, that pointer we are converting into our required data type pointer. So whatever data type you write here, automatically that wide pointer is converted into that data type pointer, and that data type pointer we are assigning to our required pointer. Means usually this pointer is also of data type of whatever data type here you write. Means wide data type is converted into this data type, and PTR is also to be declared as this data type. Means the wide data type is converted into the required data type, and whose address is assigned to the pointer of correct data type. That is what this typecasting operator is used. Means PTR is of this data type, wide pointer is also converted into this data type. And see, sometimes malloc function is used for allocating the single block of memory of specified size. Means you may request the malloc function to allocate a 50 bytes of storage space. 50 bytes of storage space as a single unit is allocated to you. Provided 50 bytes of storage space should be available in the heap area of the main memory. If free space is there, then only malloc function can allocate. If free space is not there in the heap area, then malloc function cannot allocate the requested space. So in that case, it may fail. If the requested space is not available in the heap area, malloc function cannot allocate that space. So therefore, automatically it may fail. Whenever it fails, it returns a null value. That null value is assigned to the PTR. Means memory management functions, they cannot assure that always they are going to allocate the memory space whichever you are requesting. Sometimes they may fail. Why they fail means if the requested space is not available in the computer main memory, then automatically they fail. If the requested space is allocated, they return a pointer of type byte pointing the first byte of allocated memory. If they cannot allocate requested memory, then they return a null value. That null value is assigned to PTR. So therefore, every time, definitely when you are using memory management functions and when you are allocating the space using memory management functions, immediately after using the memory management function, then immediately you have to check whether the requested space is allotted or not. Because memory management functions, sometimes they may allocate, sometimes they may not allocate. So whether the space is allocated or not, you are coming to know when you check it. So after using malloc function, immediately we have to check whether the requested amount of space is allocated or not. That's what we wrote here. If required space is not available in the memory, malloc cannot allocate the requested space. Hence, it may fail sometimes. Check the space allocated before using the space for storing the values. Means if you are going to store the values in the allocated space, first you have to check whether the space is allocated by the memory management functions or not. If the space is allocated by them, then you can proceed to store the values in that allocated space. If the space is not allocated, you cannot store the values. So then what we do is simply we'll stop the program, because when you cannot store the values, you cannot go further. So therefore, it is better to terminate your program. See some examples. You can see malloc function, how it is used. I wrote pt equal int star malloc size of integer. Why I am determining the size of integer? Because we know the size of integer is different on different computers. On a 16-bit computer, the size of integer is 2 bytes. On a 32-bit computer, size of integer is 4 bytes. On a 64-bit computer, size of integer is 8 bytes. So size of integer always depends on the machine on which you are working. Sometimes we may not know on what type of machine we are working, whether it is a 16-bit computer or 32-bit computer or 64-bit computer. So therefore, if you use size of operator, immediately it will determine the size of the integer on that machine. If it is size is 2 bytes, immediately 2 bytes size of int, it is replaced with the value 2. So means you are telling the malloc function to allocate 2 bytes of space, and after allocating that 2 bytes of memory space, it returns a pointer of type void pointing out that 2 bytes of space, first byte of that 2 bytes of space, and that void pointer we are converting it into integer pointer. Void pointer is being converted into int star. Int star means void pointer is typecasted to integer, and that integer pointer is assigned to another integer pointer. Here ptr is also integer. So this is done if a malloc function can successfully allocate the memory. If the required 2 bytes of space is not available in the computer memory, then it returns simply a null value. Then ptr contains that null value. Like that, you can allocate the space required for storing one integer variable. And it is also possible, suppose if you want to store 10 integer values or 50 integer values or 100 integer values, that is also possible. For that, you can write a malloc function like this. Here, we are requesting size of float I wrote. Instead of float, you can keep here integer. This is wrong. Float, int, size of int. Means size of integer is suppose say 2 bytes. One integer size is 2 bytes. 2 into 10. Total 20 bytes space. You are requesting the malloc function. Then a malloc function will check heap area whether 20 bytes of space is available or not. If it is available, it allocates 20 bytes of space and returns a pointer pointing out first byte of that 20 bytes space. And that pointer is void pointer. And void pointer we are converting it into integer. And that is assigned to void pointer is assigned to another void pointer ptr. Means ptr is pointing out the first byte of the memory. So how many bytes of space you have requested? You have requested to store 10 integer values. Each integer size is 2 bytes. For storing 10 integers, 10 into 2, 20 bytes of space is allocated. Allocate the space required to store 10 integer values and returns a pointer to the first byte of the space. How this space is allocated, you can see here. We have assigned the address of first byte to the ptr pointer. So therefore, see total 20 bytes. In the computer main memory, each location is capable of storing 1 byte of information. Total 20 locations. But for storing one integer value, you require 2 bytes of storage. So therefore, first 2 locations together, it is used for storing first integer value. Next 2 locations are used for storing second integer. Next 2 locations are used, means next 2 bytes are used for storing third integer. Like that it goes on. So out of these 2 means these 2 are considered as one unit, and these 2, even though they are different locations, these 2, since you are using for integer, storing integer, you have requested space for storing integer. 2 bytes are combined. Each 2 bytes is treated as 1 unit. And each of these 2 bytes are accessible using first byte address. First byte address is here 1000. Using 1000. It is means the first location means 2 bytes space is being pointed out by pointer PTR. PTR is pointing out the first element address. Like that it is pointing. Total you can store all 2 bytes are considered as 1 unit. Total 20 locations. 20 divided by 2 locations each. So total 10 integer values you can store. Like that the space is allocated. Not only for integers, you can also store space required for float variables like this. Size of float. Float size is 4 bytes. So this statement is replaced with 4 bytes. The 4 bytes requires the malloc function that this 4 bytes of space is to be allocated. Then malloc function checks the heap area. If 4 bytes of space is available, then 4 bytes of space is allocated and it returns a pointer pointing out first byte of that 4 bytes space. And that 4 bytes of space means 4 locations are treated as 1 location logically. And the address of that location is assigned means void pointer is returned by malloc that we are converting into float and that we are assigning to PTR. Here PTR is a pointer which is declared also as a float. Like that you can allocate like this space for integers, space required for storing float values, space required for storing double values or character values. Like that you can allocate space for any data type using malloc. Malloc, remember, it allocates only single large block of memory. Now, malloc function can also be used to allocate the space for complex data types like structures, arrays you can use. Here we are trying to allocate the space required for a student structure. Student structure already we have discussed. It contains so many member fields like student hall ticket number and then student name and then marks scored by the student in 6 different subjects, all that information, total marks, percentage of the student, all these fields. And all these different data types combined together, we are calling that unit as a student structure. And whatever, how much space is required for storing one student information, we are determining using size of operator. Size of operator will determine the size required for storing one student details. And that amount of space we are requesting the malloc function to allocate. A malloc function will determine whether that amount of space is available in the heap area or not. If that amount of space is available, then it alerts that space, required space, and returns a pointer of type void pointing the first member field of that student structure variable. And that void pointer we are converting it into a pointer which can point out the addresses of student structure. And that address we are assigning to PTR, where PTR should also be declared as a pointer which point out the addresses of student structure variables. So this will be done if the memory is available, then only it is done. If the memory is not available, simply a malloc function returns a null pointer, and that null pointer will be stored in PTR. So this is how in a diagram format. Suppose assume that a student structure, here struct student structure is defined with 3 member fields: student name, student hall ticket number, integer type data, and total marks of the student, that is also integer type. 3 member fields. For storing name, we declared the name as array of characters. Maximum of 10 characters it can store. Each character occupies 1 byte space. For storing 10 characters, 10 bytes of space. Hall ticket number is declared as integer. We assume that integer occupies 2 bytes on your computer. And then total marks is also declared as an integer. And since it is also integer, it requires 2 bytes. Total to store a student details with these 3 member fields. How much space is required total? 10 plus 2 plus 2. Total 14 bytes space is required. And this space, first malloc function will check whether it is available 14 bytes of space. If it is available, then it allocates that space and keeps a pointer pointing out this space. Usually it points out the first member field in that space, PTR pointer, and that address is assigned to PTR pointer. Like that we can use a malloc function. Let us see one program how a malloc function is used to store integer values. N integer values we would like to store. See here we have included stdlib.h library also, because we are going to use exit function. Whenever you use exit function, it suddenly terminates the program. Exit function, since it is defined in stdlib.h library, so whenever you are using exit function, you must include this library to your program. See the main program. In the main program we have declared two pointers. One is p pointer and another one is ptr pointer variable, and both are the pointers which can point out the addresses of integer data type variable. P and ptr declared as two pointers, they point out the addresses of integer variable. N is a normal integer variable. First we will ask the user how many integer values are there to store. So that value, suppose user may be having 5 integer values, then he will enter a value 5. That value 5 is stored in variable n. Then we will allocate the space. See, the important code is written in red color, so that you can concentrate on the core logic of the program. See, n value is 5. 5 into size of integer. Integer size usually 2 bytes. Assume that it is 2 bytes. 2 into 5, 10 bytes. You are requesting the computer malloc function to allocate 10 bytes of space during the runtime. Then it allocates if the space is available in the heap area. Then returns a pointer pointing out first element of that 10 bytes of space, and converting that pointer into integer pointer, and that is also assigned to PTR, because PTR is also declared as integer. It points out the addresses of integer. Now check whether a malloc function is successfully allocated or not. We know if the space is allocated a malloc function, then it returns a pointer, and that pointer is assigned to our PTR pointer. If a malloc function fails to allocate the required space, then it assigns a null value to PTR. So therefore we are checking here. If PTR value is equal to null, then we can we can display a message to the user that sorry, required space is not available. Then immediately we will terminate the program by making a call to exit function. And this code is not going to be executed if this condition is true. PTR value if it is null. When PTR value will be null, if a malloc function fails to allocate the space, then it will be null. Suppose if the space is allocated, then PTR value is not null, because PTR is going to point out the address of the first byte in the allocated space. Then you can read the integer values. N integer value. You are asking the user to enter n integer values in a row, and we are using now PTR is a constant pointer pointing out the first byte in the allocated space, and that address you are assigning to P. Yes, and P, as long as it is less than PTR plus N. PTR is pointing out the first byte address in the allocated memory space, first byte address, plus N. N means you have requested the space for storing n integer. PTR plus N. N means suppose N value is 5 integer values. PTR if it is allocated the address, PTR if it is pointing out address 1000, then 1000 plus 5 means you are incrementing the pointer value by 5. Every time a pointer is incremented, it is incremented by its scale factor. For integer, scale factor is 2. You are writing here PTR plus n value is 5. PTR plus 5 means you wanted to increment pointer value 5 times. Every time it is incremented by its scale value. For integer, scale value is 2. 5 times if you wanted to increase, every time it is incremented by value 2, because scale factor is 2 for integer. 5 into 2 means pointer value is incremented by 10. Means pointer value if it is first byte address is 1000 plus 10 means up to 1010. So if p value, starting address we are assigning to pointer p. P value is 1000. 1000 is assigned to p. So p is less than, here ptr plus n means it is 1010. 1000 is less than 1010. So therefore statement is true. It reads first integer and stores in at the address pointed out by p. P is pointing out now address location 1000. At 1000 location it is stored. After storing the 1000 location means 1000 and 1001 location, both 2 bytes are used for storing integer, because each integer we are assuming that it is occupying 2 bytes of storage. Computer memory, each memory location storage capacity is only 1 byte. 2 bytes means 1000 location, 1001 location. It is treated as 1 unit. Already we discussed. And p, after storing integer value in first 2 bytes locations, then p plus plus. P plus plus means pointer value you are incrementing by 1. Every time pointer value is incremented by 1, it is incremented by its scale factor. Previously p value is 1000. For integer scale value is 2. Means you are requesting here computer to increment p value by 1. P value by 1 means one time you want to increment means it is incremented by scale factor 2. So 1000 it becomes 1002. 1002 is less than 1000. So again it reads another value and stores at 1002 location. 1002 and 1003 are used address locations. Then p value becomes 1004. 1004 is less than 1010. So therefore again it reads third value and stores at location 1004 and 1005. And p value is incremented. At present value p value is 1004. You are incrementing by 1. 1 means 1006 it becomes. 1006 is less than 1010. So like that it reads next value and stores. It becomes 1008. 1008 is less than 1010. It reads last fifth value and stores at 1008 and 1009 location. P plus plus. 1008 is the previous value. Now it becomes 1010. 1010 is less than 1010. So it will stop. All 5 values are read and stored in different location: 1000, 1002, 1004, 1006, 1008 locations. Now we are printing the values. Again ptr is constantly pointing out 1000 location. Again we are assigning 1000 location value to p, and it will go up to p is less than 1010, p plus plus. So every time we are printing at this percentile star p, we wrote star p value means star p means p means address, star p means the value stored at that address. Whatever value stored at the 1000 address, it is printed. P value means 1000. Means suppose at 1000 address you have stored value 10. Then it will print the message like 10 is stored at the address location 1000. Like that. Then p value is incremented by 1. Means it becomes 1002. 1002 whatever value stored here, it is printed. Like that this program is executed. And same program can be done using dynamic arrays. See here, in malloc function, if you carefully observe, if you are having 5 integer values, we are requesting the space required for storing only 5 integer values. We are not asking any more extra space. If you are writing the same program using arrays, you may be declaring array size as 20 and you may be working with only 5 integers. And other space is wasted. But here there is no waste of space. That is the important thing here. And that program 1, whatever we have discussed just now, it is nothing but a dynamic array where you have stored a series of values, 5 integer values. Same program I will write differently using array index numbers. Like this. See, same program. Enter how many integer values are there. Scanf %t. Suppose user is having 5 integer values to store. We are storing n is assigned value 5. Then we are allocating the space. Same statements. We are checking then whether malloc has allocated the requested space or not. We are checking. And if it is not allocating, we are printing a message and stopping the program. If malloc allocates the space, then we are reading the elements. See here, I have used for loop. PTR is pointing out the address of first location. So since that PTR is pointing out address of first location, the PTR can be used as an array like this. See, PTR of I. When I value equal 0, it point out the first element like array index, PTR of I, means PTR now acting as a dynamic array. So this statement, when I value equal 0, PTR of 0 means index location 0, first element location, value is stored. Then I plus plus, I value becomes 1. 1 is less than 5. So then PTR of 1, in the second location element is stored. I value becomes 2. 2 is less than 5. So then PT of 2 means third value is stored. I becomes 3. 3 is less than 5. PTR of 3 means fourth element is stored at index location 3. Then I value becomes 4. 4 is less than 5. PTR of 4. 4 means fifth element is stored at index location 4. Then I becomes 5. 5 is less than 5. It stops. In the same way we will print using PTR. For I equal to 0, I is less than n, I plus plus, and then printing. PTR of I, PTR of plus I. PTR of I means it is just like, means we are using PTR as a pointer. Once memory is allocated, then we are using PTR as a array, dynamic array. Means same program. There we have used in the previous program, we have used pointer here. Another pointer, P equal to PTR, P is less than PTR plus N, P plus plus, like that we wrote. Here we are using that as a array. PTR directly we are using it as a dynamic array. Dynamic array means this is the space that we have created at a runtime for storing exactly whatever number of values we are having, whatever space is required for storing those values, we have requested for exactly that amount of space, and then we are storing. It is called dynamic array. So malloc function can be used for creating dynamic arrays for storing a series of integers or series of float values or a sequence of some character values, like that. Now coming to the calloc function. This is the second memory management function. Calloc stands for, C means contiguous, alloc means allocation. So contiguous allocation of memory is done by calloc function. That is the meaning of calloc. C stands for contiguous, alloc stands for allocation. Contiguous allocation of memory is allocated, means contiguous means it is used for allocating the memory locations which are sequential, one after the other. So that sequential memory locations are called contiguous memory locations. Calloc function is used to allocate multiple blocks of memory. Multiple blocks of memory is allocated using calloc function, where malloc is used only to allocate single block of memory. Calloc is used for allocating multiple blocks of memory. Then out of these multiple blocks, each block is of same size. That is the condition. The syntax is very simple. Calloc, how many blocks you want to allocate and what is the size of each block. Block size must be mentioned as an integer value. It is treated in bytes. 10. If you write 10 here in the block size space, it is treated as 10 bytes. Block size is 10 bytes. And how many such 10 byte blocks are required? The 10 value you have to write here. And if that amount of space is available in the heap area, calloc function returns a pointer pointing out the first byte in the first block. And it is a void pointer that is converted into the required data type and assigned to the PTR. Here PTR is also of this data type and void is converted into this data type. Both should be of same data types. This is done if the required amount of space is available in the heap area. If required amount of space is not available in the heap area, then it returns a null value. So then PTR contains null. So therefore we have to check before using, like in malloc, we have to check whether calloc has allocated required amount of space or not. If it is allocated, then that space can be used for storing the values. Otherwise, we stop the program. So this is the statements that we wrote, whatever we discussed just now. If required space is not available in the memory, it cannot allocate the space. Hence, it may fail sometimes. If the space is allocated, it initializes all elements with 0 value. In malloc, no initialization is done, but in calloc initializes all elements with 0 value. then it is calloc function is widely used to allocate the space for arrays and structures. Malloc can also be used to allocate the space for arrays and structures, but calloc, since it is having capacity to allocate multiple blocks of memory, so therefore it is widely used. It is more efficient than malloc function. So calloc is widely used for allocating the space for arrays and structures. Like in malloc function, after making a call to calloc function, it is definite to check the space allocated before using that space, because we should ensure that space is allocated by calloc. If the space is not allocated, doing all storing operations is waste. There is no meaning. So before using the calloc function, you have to check whether the space is allotted by calloc function or not. Example, simply you can write the statement like this: calloc n means how much space is required, for how many elements space is required. Student structure, each student structure stores one student details. For storing one student details, how much space is required? For storing, suppose say one student details, if you require 25 bytes of space, we will write here 25. And if you have 30 students, n value becomes, we will write here 30. 30 comma, we are writing 25. 25 bytes of space is required for storing one student details. Like that, we want to store 30 students details. So 30 comma 25. That is the meaning. Like that we have to write. Means you want to allocate 30 blocks of memory space, and each block size is 25 bytes. That 25 bytes block is used for storing one student details. And then it returns, if that amount of space is allocated, then it creates a pointer of type void, which is pointing out the first byte of the allocated memory space, that we are converting into again struct student data type, and that is assigned to pointer PTR. So pointer here PTR is also of same type, struct student type. This is done if the memory space is available. Otherwise, calloc function returns a null value. That null value is assigned to PTR. So therefore, it is best to check after making a call to calloc function. Again, whatever program we wrote for malloc, same function program we will write here to store n integer values. Statements are same variables are also same. See how many integer values are there. That value we are asking the user. If user is having 5 integer values, he will enter n value as 5. And then we are making a call. Here only there is a change. In the previous program, here we wrote malloc. Now we are writing calloc. And size n means n value is 5, because 5 integer values are there. And size of each integer is 2 bytes. Means we are requesting the calloc function to allocate 2 bytes of blocks. How many blocks? 5 blocks. Each block size is 2 bytes. In each block we store one integer. Means it is nothing but 5 blocks of storage space. Each block contains one integer value. Means it is a array, dynamic array containing 5 blocks. In each block one integer value is stored. Okay. And it returns a pointer pointing out first block, and that we are converting it into integer pointer, because it returns a void pointer, that we are converting into integer, and that integer pointer we are assigning to variable PTR. Now we are checking whether PTR means calloc function successfully allocated the space or not. If PTR value equal to null, we know that it has not allocated the space, because space is not available. So therefore we are stopping the program by making a call to exit function. Suppose if the space is not available and it is allocated, then PTR point out the space. So therefore PTR value is not null. Then it executes this statement. Enter all integer values. Same statement, whatever we wrote there, same statement we wrote. Again, printing the values stored at that memory location along with the values and their addresses. Same program, only the difference is only here. And this code is also same. Only here a little change. calloc function. Similarly, second program. This is also very similar to the second program we wrote with malloc function. Same statements everywhere. Only here there is a change. calloc n size. And here we will read. It is in the form once memory space is allocated, then we are reading integer values, and this PTR we are using as an array like in previous program. That's it. Same, again displaying the values of the array. Nothing is there, no change except only one statement in both the programs compared with the same programs which we wrote for malloc function. That difference you have to find out. Then realloc function. What is the use of realloc function? Realloc function means reallocation. Realloc means allocation of memory. Means the memory space allocated by either malloc function or calloc function can be modified by using realloc function. Means you can increase the space or you can decrease the space allocated by either malloc and calloc, because in real-time applications initially you may assume that you may be having only 10 values to store, so therefore you are requesting the space for 10 values, and after storing the 10 values you may find that 3 or 4 more values are there, so therefore there is a need for storage space for storing these 3 or 4 values. Then immediately you can reallocate that space by making a call to, means you can request for additional space by using reallocation function. Or sometimes it can be in the reverse way. You have requested for space of storing 10 integer values, but when you really storing the integer values, you may find that only there are 6 values. Since you have requested for space for 10 integer values and you have actually only 6 integer values, you are not going to use the space for other 4 integer values. So that space you can release again by making a call to realloc. Only 6 element space you can preserve and 4 element space you can release, so that it can be used by the computer for other purposes. That can be done using realloc function. So realloc function is used to modify the space size allocated by malloc or realloc functions. You may increase the previously allocated space or you may decrease the previously allocated space. And its syntax is like this. PTR is the pointer of appropriate data type is equal to realloc function, same PTR. This PTR is pointing out the previously allocated memory space. First byte address of the previously allocated space, then new size. How much size you want? That new size may be bigger than the previously allocated size, or this value may be less than the size of the previously allocated memory. So that new size you have to mention. Then that new size, whatever you mention, large value or small value, that amount of space is identified by the realloc function in the heap area. Then all values, whatever is pointed out by PTR in the previously allocated space, whatever value it has stored, all that values are copied into new region. And then that address of new region is assigned to the pointer. Okay, that is how it is done. Means in the previously allocated space, if you have stored any value, and all that values are copied into the new location allocated by realloc function. That new location may be a different location than the previously allocated location, or sometimes it may be the same location, because if you are requesting for more area, immediately to the previously allocated space, beside it, if you are having the free space, previously allocated space is extended to occupy the free space which is there beside it. Okay, immediately beside it, if doesn't have the required amount of space, then realloc function may search for the another area in the heap region, and that new space of required size is allocated, and all the values from the previously allocated location are copied into the new location. Means your data is preserved even though you are increasing or decreasing the size of the memory. And if it cannot do, what it will do is simply it returns a null value to the PTR and your data will be lost. But usually it may not happen except in extreme conditions where the size of available memory in the heap area is very less. So then it may happen, but in most cases it will not happen. In 99% of the cases you are not going to lose the data. Realloc function is having capability to allocate space at the other place in the heap area and copies your data. You are not going to lose your data. That is the use of realloc function. If required space is not available in the memory, it cannot allocate the space. Hence, it may fail sometimes. When it fails, your old data will be lost. If space is allocated, the values are copied from old location to the new location. But anyway, when you make a call to realloc function, it is always better to check the space allocated before you are going to use that space for storing the values. Again, example, how you can use. Assume that you are having integer pointer. PTR is an integer pointer declared as integer pointer. Using a malloc function, initially you have allocated the space required for 5 integer values. And then you can modify that space to store for 10 integer values by using realloc function. So realloc, old pointer name is PTR, pointing out this, the space allocated previously for 5 integer values, that space. And then now you want space for storing 10 integer values. So all that 10 integer values, whatever space is required for storing these 10 integer values will be searched in the heap region of the main memory, and if that space is found, it will allocate that space and assigns the address of that space to the PTR pointer. Okay. If that space is not found, then it returns a null. If that space is found, it returns the address of the first byte of that region to the PTR pointer and copies all 5 old values from the old location to this new location. New location is having a size much larger than the old location. Old location size is only 5 bytes block. It is a 10 elements block. It can store 10 integer values. So that is how it is done. You can go through one program. See here, it can store how malloc and realloc functions are used. N is used to store the number of elements, and afterwards we are going to modify the space allocated by malloc function. See, initially we are asking the user how many integer values are there. User may be having 5 integer values to store. N value he will enter it as 5. Then we are using calloc. You can use calloc or malloc function for allocating the space for this integer value. Here we have used calloc function for allocating the space for storing 5 integer values. N value is 5. Then we are checking whether calloc successfully has allocated the space for 5 integer values or not. If it has failed, then it returns a null. That null is stored in PTR. If PTR value is null, we know that space is not allocated by calloc. So therefore we are closing the program. If calloc can successfully allocate the space, then PTR point out the address of first byte. So therefore it is not null. Then it reads the values, and all that values we are storing using pointer P. P is made to point out initially first byte, and from there it goes on moving. PP. Pointer P is moving to the next location for storing the values, and then it will display the same program. Program statements are same, whatever we discussed in the previous program. Same programming statements are there. So therefore just go through the lines. I am not explaining. Same thing. Here there is a difference. Now previously we have stored only 5 integer values. Now user came to know that few more values are there to store. So therefore here we are asking the user, enter how many more values you want to store. Previously he entered that only 5 integer values are there. So therefore he felt that only 5 integer values he is going to store, and he entered n value as 5. Now after storing 5 integer values, he felt that few more integer values are left over. Then so therefore we need to allocate some more space. So we are asking the user how many more values are there to store. Suppose user may found that 3 more values are there, 3 more integer values. So m value he may enter as 3 more values. M value is 3. So total space required for us is previously 5 integer values, now 3 integer values. So total 8 integers. So modified value of m is nothing but m is equal to its old value given by the user as 3 plus n value, previously stored integer values 5. So 5 plus 3. Now the latest value is 8. We need one contiguous space for storing 8 integer values. Already 5 integer values we have stored in the previously allocated location. But now user found that 3 more values are left over. So therefore he wanted to have storage space for 3 more elements. Already space for 5 elements are allocated. That 5 elements total 3, these 3 elements. At one place we will allocate the space required for storing 8 elements. We will request, see, using realloc function PTR. Now m value is 3 because we have modified m value. User has given m value as 3. We have added new value of m is nothing but its old value of m plus n. N value is 5, m value is 3 given by the user. 3 plus 5. 8 is the latest value of m. So we are asking the realloc function to allocate the size for storing m integer values, m integer values. And previously PTR is pointing out a location where only 5 integer values are stored. So we have given that PTR which is pointing out the storage space where only 5 integer values are stored. And then we are asking the realloc function to allocate a contiguous space where 8 elements can be stored. Then realloc function searches the heap area. If contiguous space for storing 8 elements is found, then it will allocate the address of first byte to the PTR pointer. See here. Then we will check first initially whether it is required space is allotted or not. If PTR value is null, we know that it has not allocated. It is not successful. So therefore we are stopping the program. If it is successfully allocated, then PTR value may not be null. So therefore we are printing the message that required space is successfully allocated. And it copies all old 5 values to the new location where the space for 8 elements are allocated. Then from that location again we are printing all that 5 values. And this new location sometimes may be same or sometimes it may be different, as we discussed previously. Means after the 5 elements still space is there, continuous space for 3 more elements. The same space is continued further to accommodate 3 more elements. If the space is not available after this after this block of memory is to store 3 more elements, then completely realloc function allocates a space in some other area of the main memory to store 8 integer values. So therefore because of that reason, sometimes you may have the same location, sometimes you may have different locations. Okay, that you have to remember. Then free function, the name itself indicating that free function is used to release the memory space allocated by malloc and calloc functions. The memory space whichever you are not using, that you can release it so that the computer can use that space for some other purpose. What is the syntax for releasing the memory space? Syntax is very simple. You can write free and pointer. This pointer is nothing but it is pointing out the block where the space is allocated by malloc or calloc function. If you give that the first address of that block allocated by calloc and malloc function, all that block will be released by the free function. Releases the space pointed out by the PTR pointer. You can write a program. Same program we will write, except that at the last we use C. Here we are writing a program for storing n integer values using malloc function and free function. Same program, same statements. Enter how many integer values are there. N integer values, n value may be 5. And then come here. We are using a malloc function to requesting the storage space for storing n integer values. And if successfully it can allocate, it returns a void pointer that we are typecasting here and allocating the address of first byte to PTR pointer and checking malloc whether it has allocated the space or not. And if it has allocated space, these statements are going to be executed. If the space is not allocated, it is making this condition becomes true and it prints this message and makes a call to exit function. Program is terminated there itself if the space is not allocated. If the space is allocated by malloc function, PTR value is not null, so this condition becomes false, then this code is getting executed. What is that code? Enter how many integer values, all integer values in a row, n integer values they said, user said, so therefore it is asking the user to enter all n integer values. We are reading that integer values using pointer p and then storing it at the appropriate locations and then we are printing the values. And after printing the values, since our job is over, we have taken values, stored there, and we have displayed the values. We are freeing that memory. That memory is pointed out by pointer PTR, so therefore we are releasing the memory by making a call to free function. And then we are displaying the message. The memory allocated at runtime has been released. So then we are closing the program. This is how you can use free memory allocation function, which can be used for releasing the space occupied by the allocated by the malloc function or realloc function or calloc function. Okay, then some programs for your practice. So these three programs, just you go through these three programs. First program is using malloc function, which can store n integer values, and it determines biggest of those integer values. Then it will display all that integer values where they are stored along with their values and their addresses, and then along with the biggest element. So this is nothing but you are creating a dynamic array using a malloc function for storing n integer values. Same program we wrote already. This program is written. Only the extra thing you are doing here is determining the biggest of n elements, and that biggest value you are displaying on the screen. Then same program you are also asked to write using calloc function. Here only the change is store float values and print that float values along with their addresses where they are stored in the memory. And third program is here you are asked to write the program for storing student details. You can store n student details, means array of structures you can declare, and this array is a dynamic array. Dynamic array means if you have 10 students in the class, only the space required for storing 10 student details you can allocate, you can request, and only that 10 students details you can store. If you have 50 students in the class, request for the space required for storing 50 student details, and then you can store those 50 student details in the blocks. Each block contains one student details. 50 blocks, 50 students details, and display all that student details. That is third program. So means all these programs are making use of dynamic arrays. Then what are the important questions? The first question covers everything. List and explain the functions used to allocate and releasing the memory dynamically with suitable one program for each function. With a suitable program, one for each function. Okay. So we have discussed three memory allocation functions: malloc function, calloc function, realloc function. So for each function, you write the syntax for each of these functions and how it is going to allocate the space, and then one program for malloc function, one program with calloc function, and one program using realloc function, and then free function. What is the use of free function? Free function is used for releasing the space allocated by either malloc or calloc functions. How that free function is used, that also you write one program for free function. So 4 programs and 4 functions you have to write. It covers everything. And second question was asked many times in the exam, that is, write the syntax for malloc function and discuss with a program what is that function and how it is used to allocate the space at a runtime. So you write the answer for only first question, because in the first question the second question is also covered. So therefore write the answer for only question number 1. So this is the assignment, and yesterday I have given assignment. Around 3 assignment questions I have given in the yesterday video. So those answers for those 3 questions and answer for this question. Total for 4 questions you have to write the answer, and you have to submit it by tomorrow 1 p.m. And listen to these video lectures, all video lectures carefully. In the YouTube you can just type C language video lectures by Madhira Srinivas. C language video lectures by Madhira Srinivas. You will get all my videos, C language related videos. And I am trying to create few more videos for second unit and third unit, so that on whatever topic you are having the doubt, you can open that particular video and listen to it carefully and take down the notes, because when I am going through the slides, I am explaining all the points. So those points, whatever is written on the slide, more than that I am explaining. So all that notes you have to take, and then you read this notes by listening to video lecture, and if you take notes, and that notes is enough to you to prepare for your examinations. Even you need not read any textbook. This notes, if you write perfectly, class notes, and if you read that notes from this video lectures, it is more than sufficient to score 100 out of 100 marks. And sincerely practice all these assignment programs given to you. And first practice the example programs discussed in the video lecture, and then try to do the programs which are given as assignment to you. Programs, whatever programs are given for practice, that programs you try to implement on your own, so that you will get confidence in writing C programs. Okay. Thank you all for your patience listening. And if you have any doubts, you can replay the video and go through it. Still, if the doubt is not clear, you can call me on my personal mobile number 9848919656 between 9:30 and 5, but after 5 don't disturb me. And then thank you all, and in the next class we are going to discuss searching techniques. After searching, we are going to discuss few sorting techniques. With that, the syllabus of PPS will be over, and it may take 3 or 4 videos to complete the 5th unit. This is the last video for 4th unit. Okay, and next week onwards we are going to start the 5th unit in our syllabus. So thank you all. Thank you once again.